In this video, we will practice factoring using the greatest common factor, or GCF, and factoring using the difference of squares pattern. So for the first four problems, we're going to factor by only using the GCF, but the directions warn us that one of these problems has no GCF other than one. So we will note that when we come to it. Okay, so looking at problem number 13. First, we look at the variables. Do both of the terms have x's? Yes. So since they both have x's, that means there will be x's in the GCF, which we will put out in the front. But we have to decide how many x's to put in the GCF. Well, look, the first term has 3 x's. The second term has 2 x's. What's the lower amount that I just said? 2 x's. So that's how many x's go in the GCF. So out in the front, I'm definitely going to have x squared. Okay, now look at the y's. Do both terms have y's in them? Yes. The first term has 1y. The second term has 1y. So I will definitely put 1y in the GCF. Now, finally, I look at the numerical part, and I ask myself, is there anything other than 1 that divides evenly into 8 and 15? And in this case, the answer is no. The only thing that will divide into 15 is 3, 5, and 15. None of those divide into 8, so there will be no number part of the GCF. So this is the GCF, x squared y. Once you have identified the greatest common factor, what you want to do is divide by that greatest common factor. I'm going to divide by x squared y. Because that lets us know what will go inside the parentheses. So look, the 8 is going to just stay there. So if we have x to the third power divided by x squared, that's going to simply be x. Now you can think of that as subtracting, right? 3 minus 2 is 1. That's why I just have 1x. Or you can think of it this way. If I have x to the third power over x squared, x to the third power really means x times x times x. X squared really means x times x. So two of the x's will cancel each other out. And that's going to leave 1x. So that's another way of realizing why we just have 1x. Anyway, the y's will definitely cancel out. So no y's. And then I'll have plus 15. And that's all. The x's will completely cancel out, and the y's completely cancel out. So this is the final answer for number 13. Okay, how about number 14? Let's start with the variables. Do both terms have x's? Yes. The first term has 5, the second term has 2. What's the lower number I just said? 2. So that's how many x's will be in the GCF, x squared. Next, I look at the numerical part. What's the biggest number that divides evenly into 12 and 3, other than 1? Well, 3. 3 itself goes into 3 and 12. So there will be a 3 in the GCF. So the greatest common factor is 3x squared. Once you've identified the greatest common factor, go ahead and divide by the greatest common factor. Because that will let you know what goes inside the parentheses. Now 12 divided by 3 is 4. X to the fifth power divided by x squared is x to the third power. 5 minus 2 is 3. Now be careful here. Some students will just leave this blank, and that would be wrong. This should be minus 1. So sure, everything cancels out, but that doesn't make 0. When you cancel things out, you really are making 1. And think about it this way. Ignore the x's for a second. Just look at the fact that we have 3 over 3. What did you learn back in elementary school? What is 3 divided by 3? 3 divided by 3 is 1. So yeah, when you're canceling things out, what you're really doing is you're turning everything into ones. Okay? So if everything cancels out, it's really a big old 1. So that's the final answer. For number 15, let's start with the variable part. Do all of the terms have a's in them? No, the last term has no a's. Do all of the terms have b's in them? No, the last term has no b's. So there will be no variables in the GCF. So now we look to the numerical part. What's the biggest number other than 1 that divides into 5, 10, and 30? Well, the number 5 itself goes into 5, 10, and 30. So that is going to be in the greatest common factor. So I'm going to definitely have a 5 out there. Actually, I meant to use a different size ink. So let me do that again. 5. Okay, except for one thing. If the leading coefficient has a negative, go ahead and include the negative as part of your GCF. So we will use -5 as the greatest common factor. So now go ahead and divide everything by -5. And that will tell you what goes inside the parentheses. So -5 divided by -5 is 1. So I don't need to write a number 1, so I'll just put a squared b. 10 divided by -5 is -2. So I'll have -2ab. -30 divided by -5 is +6. So this is the final answer. Now, taking a glance at number 16, let's start with the variable part. Do all of the terms have x's? No, the last term has no x's. Do all of the terms have y's? No, the middle term has no y's. That means there will be no variables in the GCF. Okay, now let's look at the numerical part. Other than the number 1, what's the biggest number that divides into 6, 11, and 4? Well, there is no number other than 1 that divides into 6, 11, and 4. 11 is a prime number. It's only divisible by 1 and 11. And 11 doesn't go into anything else. So there are no numbers in the GCF. There will be no variables. So there is no GCF. So this is prime. For the next 4 problems, we will factor using the difference of squares pattern, if possible. Now, the difference of squares pattern worked like this. The difference of squares means you are subtracting 2 things that are being squared. So the word difference means subtraction. So when we talk about squares, we mean like a squared and b squared, for example. So in its most basic form, this is what the difference of 2 squares looks like. Something squared minus something squared. And it turns out that when you factor the difference of 2 squares, it factors like this. Okay, a plus b times a minus b. All right? So this is the difference of squares pattern, and we're going to use it here. Okay, so number 17 fits the difference of squares pattern. 16 and 25 are both squares, and x to the 6th power and y squared, those are both squares. And here's why. All right, I can show you while writing the answer. So 16 is the same thing times itself, because that's 4 times 4. Okay, somebody's birthday out there. So that's why 16 is a perfect square, because it's 4 times 4. Now, x to the 6th power is also a perfect square, because that is also something times itself. X to the 3rd power times x to the 3rd power. Remember, when you multiply variables, you add the exponents. So this would be x to the 6th power. And it's the same thing twice, so that's why this is a perfect square. So for this pattern, as we saw, 1 will be positive and 1 will be negative. Now 25 is 5 times 5, and y squared is y times y. So this is our a plus b and our a minus b. Now, number 18 is not the difference of squares, because it is a sum. Okay? Difference means subtraction. So, if it's addition, that's not the difference of two squares. So the sum of two squares can't be factored. Now, number 19 is back to fitting the pattern. Okay, this is going to be a plus 9. Wow, okay, I really wish they didn't use a. And this is going to be a minus 9. Okay, a lot of our a's look a lot like 9s, so this is like the worst possible problem. Okay, a plus 9, a minus 9. Boom. Number 20 also fits the difference of squares pattern. X squared is x times x. Okay, we'll go plus and minus. 9 is 3 times 3. And y to the 8th power is y to the 4th power times y to the 4th power. So that's difference of squares. Now, for the remaining problems, we're going to do a combination of difference of squares and GCF. We always will do the GCF first if it exists. So let me zoom in. So let's factor out the greatest common factor. Do both terms have x's? Yes. So that means my GCF will have x's. But how many? Well, the first term has 3, the second term has 1. So the lesser amount is 1, so that's how many I can bring out. Now let's look at the numerical part. 4 and 36. What's the biggest number that divides into 4 and 36? Well, 4 itself goes into 4 and 36. So that means the GCF will be 4x. Once you have the greatest common factor, divide by it. So I'm going to divide both of these terms by 4x. That tells me what's going to be left inside the parentheses. So this is going to leave x squared minus 9. Okay, the 4's cancel out, the x's cancel out. X to the 3rd power divided by x is x squared. You can think of it as subtracting if you really want to. 3 minus 1 is 2. Or you can think of it the way I do. X to the 3rd power over x. X to the 3rd power is x times x times x over x. So one of the x's will cancel out, and that's why you get x squared. Anyway, looking at the parentheses, hopefully you can see that this fits the difference of squares pattern. So I can continue the factoring process and do x plus 3 times x minus 3. And then I will just bring down that GCF. So this will be the final answer. Okay, let's do the same thing for number 22. Let's start with the variable part. I see an x here. Do both terms have x's? No. Only the first term has x's. So there will be no x's in the GCF. Do both terms have y's? Yes, they both have y to the 6th power. So that means y to the 6th power will be part of the GCF. Look at the numerical part. Well, the first term only has a 1. So other than 1, there can't be a number that divides into both. So that means that y to the 6th power is the GCF. So I will now go ahead and divide both terms by y to the 6th power. That will tell me what is left inside the parentheses. So that's going to be x to the 6th power, because the y's cancel out, and minus 36, because again the y's cancel out. Now hopefully you can see that this fits the difference of squares pattern. So I can go ahead and factor this blue part. So this will be x to the 3rd power times x to the 3rd power. Okay, because when you multiply, you add the exponents. And it'll be plus and minus, and then 6 and 6. Okay, and then you just bring down the GCF. Okay, so this should be the final answer. All right, in the next few problems, we will continue to use a combination of factoring out the GCF and using the difference of squares pattern. But we're not guaranteed that the problems will involve both of those. We'll just have to use our judgment. And the directions tell us that one of the problems is prime. So one of the problems can't be factored at all. So looking at the first problem, looking at number 23, are there any variables? Are there x's in both terms? No. The 25 has no x's. That means there's no variable common factor. Now look at the number part, 9 and 25. There's no number that divides evenly into those. So there's no GCF. So let's move on to the difference of squares pattern. Well, this does fit the difference of squares pattern, because 9 is 3 times 3. Of course, x squared is x times x. So we can go ahead and do plus and minus. And then 25 is 5 times 5. So this should be the final answer. Okay. Now, what about this? Both terms do not have x's, so there's no variable common factor. 25 and 36 cannot be divided by the same thing. So there's no GCF at all. So maybe it's going to be the difference of squares pattern. But no, for the difference of squares, this has to be subtraction, not addition. So this doesn't fit the difference of squares pattern. It has no GCF. So this problem is prime. Oh, okay, I guess we're supposed to indicate which methods we used. So on number 23, we just did the difference of squares pattern only. And on number 24, it was prime. Okay, I forgot to mark that. Okay, let's look at this one. First, let's look for GCF. Do all of the terms have x's? No, the last term has no x's. Do all of the terms have y's? Yes, they do. They all have y's. So that means there will be a y common factor. Now, numerically, there's only the middle term has a number other than 1. So there will be no number for the GCF. So there is a GCF. It's going to involve y. However, because there's a negative in the front, I am going to include that negative sign as part of the GCF. So my GCF is going to be negative y. Okay, so I'm going to now divide everything by negative y. and see what I get inside the parentheses. So a negative divided by a negative is a positive. The y's cancel out, so I will have positive x to the third power. This term will be negative, so negative 4. The y's cancel out, but I still have x squared. Now, please be careful. These cancel out, but that doesn't mean I have nothing. Anything divided by itself is 1. So there should be a positive 1 right here. Now, so we definitely use the GCF. Look at the remaining part inside of the parentheses. Does this fit the difference of squares pattern? Not even close. This is a trinomial. So we have GCF only. And this is the final answer. Okay. Number 26. Do both terms have x's? No. Do both terms have y's? Yes. So that means we will have y's in the GCF. But how many? The first term has 4 y's. The second term has 2. So we go with the lesser amount, and that's going to be y squared. So now we look at the numerical part. Is there anything that divides into 9 and 16? No. So y squared is the GCF. So let's go ahead and divide by the greatest common factor, because that will tell us what to put inside the parentheses. So that's going to leave us with 9x squared y squared. All right, 2 of the y's cancel out. And this will leave us with minus 16 with no y's, because the y's all cancel out. So fine, we have a GCF, but will it be GCF only? No. Looking at the blue part, I can see that this now fits the difference of squares pattern. Notice it is subtraction. That makes it a difference. And 9 and 16 are both perfect squares. And x squared and y squared are both squares. So this is going to be 3xy plus 4 times 3xy minus 4. Okay, if I multiply these together, that's going to give me 9x squared y squared minus 16. And then I will bring down the GCF that we had, bring down the y squared. So this will be the final answer. So for this problem, we used both GCF and difference of squares. Paula tried to factor out the GCF of a polynomial, and she got this for her answer. Explain how you can tell that Paula didn't factor out the greatest common factor. Well, look at her answer. Look at what's inside the parentheses. Can you see that they both still have an x in common? So that's how you know she did not factor out the greatest common factor. All right, so like I said, both terms inside the parentheses still have x in common. That's how you know she didn't factor out the greatest common factor. So for number 28, we need to use what she's done so far to correctly factor out the greatest common factor. Basically, we have to finish what she started. So for a moment, ignore the 4x to the 5th power. Pretend that this was the original problem and we needed to factor out the GCF. Well, like we said, they both have x's in common, so that would mean we would need to take out an x as a GCF. And it will be 1x because I see 3 x's, I see 1x, so I go with the smaller amount. Now that I have the GCF, to figure out what goes inside the parentheses, I should divide by the GCF. So inside the parentheses, that's going to leave me with x squared, right? X to the 3rd power divided by x is x squared, plus 10. because these x's cancel out. So if this was the original problem, then this would be the answer. However, that's not quite what the situation was. Because of the part that she had done so far, we also have this 4x to the 5th power out front. So what you want to do is go ahead and put 4x to the 5th power out front, and you multiply. So that's why the final answer should be 4x to the 6th power. X to the 5th times x is x to the 6th power, times x squared plus 10. So this is the actual final answer. Okay, a rectangle has an area 12x squared plus 18x square units. Show that the rectangle's width and height might be 3x and 4x plus 6. Well, we're talking about area. The area of a rectangle is the width times the height. So if I multiply 3x times 4x plus 6, that should give me the area. So if I were to multiply this, I would do it by the distributive property. So 3x times 4x is 12x squared. And 3x times 6 is 18x. And then notice that this matches 12x squared plus 18x. Okay, so because multiplication gives me this expression, that means this could be the base and the height. All right, because base times height is how you get the area. This could be the width and the height. Okay, equals. So find another pair of expressions that could be the width and the height. Okay, in other words, I need something else that I could multiply to make 12x squared plus 18. So look, there's more than one correct answer, but based on what we've been practicing all this time, why not factor out the GCF? And that should be an answer. So here's the original problem again. Notice that both terms have x's. So my GCF is definitely going to have an x in it. Okay, and in fact it will be exactly 1x because that's the lesser amount. Now, look at 12 and 18. What's the biggest number that divides into 12 and 18? Well, they're both divisible by 3. They're both divisible by 6. They're not both divisible by 9. So 6 is the greatest common factor. So that means 6x would be the GCF. So if I want to continue factoring, what I need to do is divide by the GCF, and that will tell me what to put inside the parentheses. So this would be 2x plus 3. The x's cancel out. Okay, so because these are equivalent, right, the original problem, and now I have the factored form, and so here I've written this area as something times something. This could be the width, and this could be the height. So that's one possible answer. There are others. For example, instead of pulling out the actual greatest common factor, I could have just pulled out a 2, right? Both of these are divisible by 2. So that would have been another correct answer. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.